Clean water is a basic need that is very important for human life. Without clean water, various daily activities such as bathing, washing, worship, and consumption cannot run properly. Unfortunately, the availability of clean water is still a challenge, including in Mahad al-Jamia UN Walisongo Semarang. The Mahasantri and Mahad often face obstacles due to unstable clean water supply. This disruption in water supply has a direct impact on important activities, especially at crucial times such as in the morning when preparing for classes, as well as at night when they are preparing to rest. On the other hand, rainwater that falls quite often only becomes runoff and is wasted. In fact, rainwater has great potential to be utilized as an alternative water source if managed properly through a rainwater harvesting (RWH) system. However, collected rainwater can be polluted by various contaminants such as dust, heavy metals, and chemicals carried from the roof in the atmosphere. So an effective and environmentally friendly filtering system is needed so that clean water can be used for Class 2 water needs. One relevant technology is the slow sand filter, or SSF. This technology filters rainwater naturally using a layer of fine sand and natural microorganisms that form on the surface of the sand. This system is proven to significantly improve water quality without the use of chemicals. Based on this background, we from the Environmental Engineering Study Program team at UN Walisongo Semarang designed a rainwater harvesting system equipped with slow sand filter technology. The goal is to fulfill the need for clean water in Mahad al-Jamia. This research uses a qualitative method with an engineering design approach. Data was collected through 3 stages. First, passive field observations. Second, interviews with Mahasantri to find out their perceptions and needs for clean water. And third, the utilization of technical software such as Google Earth, AutoCAD, and Microsoft Excel. The main problem found was the instability of clean water supply. Therefore, we explored the potential of rainwater as an alternative. The location of Mahad in Ngalian District, Semarang City, was used as a reference to take rainfall data for the last 10 years, from 2015 to 2024. From the data, the year with the highest rainfall is 2021 at 2,710 millimeters. However, for the design, we use the percentage of reliable rainfall for clean water sources is 80%. Based on the analysis, a reliable rainfall representation that is close to 80% is selected in 2023 at 72.73%, which is 1,528 millimeter. The next step is to calculate the roof area of Mahad as a rainwater capture area. Using Google Earth and the polygon feature, a roof area of 1,024.53 square meters was obtained. This area becomes the basis for calculating the volume of rainwater that can be accommodated each month. The calculation of rainwater volume is done using the formula. For example, in February 2023, 383 millimeters of rainfall resulted in a water volume of approximately 353 cubic meters. The clean water demand based on SNI 03-7065-2005, which is 120 liters per person per day for dormitory occupancy. With 504 Mahad residents, the total daily demand reaches 60.48 cubic meters, or about 1,814 cubic meters per month. The comparison graph between the potential volume of rainwater and water demand shows that during the rainy season, such as January, February, and December, the volume of rainwater is quite high, but still not sufficient for monthly needs. Whereas during the dry season, the water volume is close to zero. In total, the system is only able to fulfill about 20% of the Mahad's clean water needs. To accommodate the available rainwater, we designed a horizontal cylindrical ground tank with a storage volume of 196 cubic meters. This size is based on the average water volume during the rainy season, which is from December to May. Using the tube volume formula, we determined a tank diameter of 5 meters and a height of 2.5 meters. The tank is buried underground to hold the filtered water before it is used. Before rainwater is utilized, it needs to be filtered first. This is important because rainwater captured from the roof is potentially polluted by various substances. Rainwater can contain CO2, O2, and NO2 gases, which dissolve and form acidic compounds such as carbonic acid, sulfuric acid, and nitric acid. These compounds cause the pH of rainwater to often fall below 6. Water with these characteristics does not meet the quality standards of Class 2 clean water, in accordance with Government Regulation Number 22 of 2021, which is used for hygiene and sanitation purposes. Therefore, filtering rainwater before use is very important. The distribution system is designed as follows. Rainwater is captured from the roof and flowed through the channel to the slow sand filter. After filtering, the water is collected in a ground tank. From here, the water is pumped to the roof tank and then distributed to the points of use in the building, is interrupted. Slow sand filter technology works naturally without the need for chemicals. Rainwater flows slowly through a layer of fine sand. At the top of the sand, a microbial layer called Schmutzdecke forms. This layer actively filters microorganisms, heavy metals, and organic substances. Based on test references, SSF is able to reduce the turbidity level from 35 NTU to around 1 to 2 NTU, raise the pH from 5.6 to around 7, and reduce the total coliform count from 180 to below 50 CFU per 100 milliliters. With these results, the filtrated water has met Class 2 quality standards, making it safe to use for sanitation and hygiene purposes. This rainwater harvesting system is not yet able to fulfill all of Mahad's clean water needs, but it can be a reliable source of water reserves, especially when the clean water supply is disrupted. This system also has the advantages of being easy to implement and environmentally friendly. In the future, this system has the potential to be applied in Islamic boarding schools, student dormitories, and other dense settlements.